Well, no, remember you're just substituting it into g of x. Alright. If I can grab everyone's attention at this point, y'all cannot forget this, and I keep saying this. What are the first points you need on your table? What points do you need to think about? The zeros. Take the time. Remember, it's called a zero because that linear factor is equal to what? 0. So that would give me, once I solve it, x equals 2. And y'all can tell me that the zeros are these values, but then you're not using that negative 1/2. You need that negative 1/2. And so you need a little bit outside of that. Remember, so negative 1/2 and 2. What I would probably do, and this is what I've recommended to some students, I'd probably go to negative 1, and then I might just go to negative 2. But I might do 0, 1/2, 1, 2, just to have symmetry there, and I'd probably need to go one more to the right. But I might do that symmetry of negative 1/2 and 1/2. I don't know for sure. It depends on how it works out. But do not forget, one, you can substitute those x values in, right? Or you could just look at what? The graph. Because when I look at an x value of negative 2, does that show up on the parabola? No, not at all. But can I substitute negative 2 in for x? Yes, Mr. Kenny. Thanks, guys. So that would give me a negative 3 times a negative 4, which is positive 12. Okay? Now when x is negative 1, I already have that value. It's right here. That's a positive 3. When x is negative 1/2, y is 0. When x is 0, y is negative 2. Good job, guys. When x is 1/2, what is y? Negative 3. When x is 1, that would be negative 3 as well. When x is 2, y is 0. And then I would have to substitute that 3 in. Alright, so that'd be 6, 7 times 1 is 7. Did someone just say 7? So there's my g of x. And I just need what else to be able to get the function? Still need x minus 2. You don't have to do that column. I just do to show where it's coming from. I'm just subtracting 2 from x. So negative 4, negative 3, negative 2.5, negative 2, negative 1.5, negative 1, 0, 1. And then we would dilate. Tomorrow when we come into class, we are starting right away on doing this. There will be no bell ringer other than to get started on these problems because we got to get through this quickly. No more than 30 minutes of class will be on this, and this will be your last set of practice with these problems. Because you have, hold on one second, you have this graphic organizer, these terms, and this practice currently due on Friday. So we need to get that practice in. Because you need to be able to practice it on your own as well.
But it don't go to
Yes, ma'am.
I got to
G of x is 2x minus 2x. You just have G of x equals Right, but the issue is those sides are over here. 2x plus 1 times x minus 2. So that threw everything off. So you would want 2 times negative 3
Say John. Say John.
times negative 3 minus 2. So that should have been
You better turn all the way around, man.
negative 5 times negative 5 would be 25. That would be 25. You substitute that negative 2 in, negative 3 times negative 4. So you need to read equals. They're a little off. And so what we would do is, so I wouldn't have this column at all. I would have had g of x here, and I would have had x minus 2 here, and so you need to redo those numbers. And it's just g of x times x minus 2. Right, because remember, the whole thing is that we're taking g of x here, and we're dilating it by x minus 2. Makes sense? So I only need g of x as a column, and I need x minus 2 as a column, then I dilate to get that last column. Does that make more sense? What's up?
Do you know when we have raised colors?
I already took it, but I don't know.
I'm assuming we still put grades in there.
I guess.
So I had a kid who didn't want here last.
I have a kid who still hasn't taken the exam.
That's what I'm saying. I hasn't taken it. So I'm taking it now.
So my plan